Afternoon, good evening, everyone, or good morning, wherever you're joining us from. You are welcome to this online event organized by Data Engineering Community. My name is Najeeb Sulaiman. If you are meeting me for the first time, I'm a data engineer and I currently work with Jaguar Land Rover UK. I happen to be the founder of Data Engineering Community, which is a community which is funded to serve as a platform where aspiring data engineers can interact with experienced professionals to gain insight to whatever problem they may be having, navigate career, and to also serve as platform for experienced data engineers and working professionals to leverage and communicate together, interact, network, and share opportunities with each other. So this is one of the events we started this year, January, which is the Demystifying Data Engineering series. So it's a series of webinars where we come together to learn together. So it's driven by the community at large, which is the data engineering community. So this is the third episode of the Demystifying Data Engineering series. Last month, we have Pascal Chukwuemeka speaking to us on Ask Me Anything session where we interact with him and we ask him a couple of questions and gain insights and career advices from him. So today we'll be having a session with Joseph Ojo. Just to introduce him briefly, Joseph Ojo is also a data engineer. He's also one of the core member of the data engineering community, and he's well experienced as well. So he has experience across fintech, across logistic industries, and I'm sure we are going to learn so much from him today. And as I've said, this is a platform for us to learn together. So as much as we are open and looking forward to learn so much from him, so we are also looking forward to learn from each other as well during the question and answer session, whereby you can ask questions and even answer some of the questions that may be asked by other participants on this call. So without taking too much time, I will leave the floor open to Joseph Ojo so that he can walk us through serverless data pipeline design with AWS services. I'm so much sure we are going to be learning so much from this and we'll have something to take away from this session. So thank you so much for joining everyone, and I hope we all gain something from this workshop. Thank you so much, Joseph Ojo, also for giving us the time and willing to share your knowledge with us. We so much appreciate it. Thank you so much.
Thank you very much, boss. All right. Hello, everyone. Good morning, good evening, good morning, good evening, good afternoon. So, like my boss has introduced me, I'm Joseph Ojo. I'm a data engineer working at an e-logistic company here in Nigeria. So today, I'm going to be talking about serverless pipeline on AWS. And this is going to be a practical section. Please let me know if you can see my screen.
Not yet from my side.
Okay, 1 second. I thought I was presenting. Okay.
Yeah, no, I can see your screen.
Okay. So today I'm going to be discussing serverless data pipeline on AWS. So over the few years that I spent in data engineering, so most times I really do come across serverless data pipeline, and I think that it's something that people really need to look into because it can be an avenue of cost savings. So I'm going to start by explaining some of the concepts that we are seeing in this title, because I understand that we have different level of people here. We have beginners, we have professionals. So some people might not actually know what serverless is or what data pipeline is. So I'm going to be starting by talking a little bit about those two concepts. And the first one will be what are data pipelines. And yeah, I am quoting my boss. So this is a conversation that was brought up a few weeks ago about what data pipeline is and what ETL means and the difference. And I love the response that Najeeb gave on the group. And he said that Data pipeline is a means of moving data from source to destination. So, and this can contain one or more components and processes. So, this definition, I hope that it's going to help explain what data pipeline is. And another definition of data pipeline or analogy of data pipeline that I so much enjoy is the one that IBM gave, whereby they likened a data pipeline to the normal water pipeline. So they said that our major source of water, drinking water, is from maybe lake, rivers, and yeah, let me say lakes and rivers. And I mean, whenever we want to use water from our home or from our factories and the likes, we don't go to those places to get water. I mean, we just go to our house on the tap and water comes out. So people have built pipes and from the source to the destination, which is our houses and factories and the likes. But we are not getting the water as it is from the source. So assuming we are getting the water as it is from the lakes and the likes, I doubt it's going to be consumable. So these people, I don't really know the architecture or the way that they build the pipelines from lakes and lakes to inside our houses, but I understand that they would have like a central reservoir where the water will be stored and treated so that it can be able to, so that a human being can be able to consume it and they will not get sick from consuming that water. So I believe that this analogy is very, very close to what data pipelines are. So if a data engineer or anybody that's in charge of moving data, just move data as it is from the source to the destination for the analyst. So it might not be safe for consumption for the analyst. So that is why this data goes through a set of processes that is called transformation so that it can be readily available for analytics or ML. So I hope that that definition at least will help someone to understand what data pipelines are. So the next one, serverless. Some people do joke that serverless is not serverless, and from the word, you might be thinking that serverless means no server, and that is not the case. I mean, serverless, there's a system server running somewhere that you're using to run your code. So now, what is the difference? The difference here is that in serverless services, you are not in charge of the underlying infrastructure to run your code. So you are only managing your code. You're not in charge of the compute that is needed, the setting up, the provisioning, the maintenance, and all those things. There is a lot of headache when it comes to running code. So serverless are services whereby you only manage your code and the cloud providers manage the other parts, the infrastructure part. And we're going to be going a little bit into why this might be something that a lot of people should be looking into. Now, to this workshop, the practical class that we're going to be having is centered around a data pipeline for Fantasy Premier League, which in short is FPL. So for the guys here and some of the ladies, they will be very, very familiar with what Fantasy Premier League is. And for the people that are not familiar with what it is, I'm going to try my best to explain it. So I just became a fan this season. So, and I was very surprised to hear that this has been available for years. I believe that it became mainstream around 2019, is it 20, about 4 or 5 years ago. So what is FPL, Fantasy Premier League Pipeline? So this is an online fantasy game that is based off the real football league, which is the England Premier League. So recently, I believe that the Champions League also roll out theirs, but this is like the most popular and that has a lot of players. And according to Wikipedia, they have about 11 million players as of the last time that they posted that. So Fantasy Premier League is an online fantasy game where participants, that means users like you and me, act as team managers. So we are going to assemble a squad for a current game week, and based on the performance of those players in real life, they are assigned a point. And in the various leagues that we are, the manager with the most points is ranked first, and the manager with the least points is ranked last. And this sometimes gives someone like pride when you are like topping your league. So at the beginning of the season, someone was teasing me about how I was in the bottom 7 managers, but thank God, at least I've moved up a bit. So that is what FPL is. And before we move into the serverless, how we're going to be the serverless pipeline, I thought about okay, we should talk about how like the sample architecture will be if we are not to use serverless services. And if this project is thrown out and people are asked to build pipelines, about 150% of the pipeline that you're going to be seeing will look like this. So I tried as much as possible not to mention name here, but I mean, if you were to guess what this is, all of us will guess it right. So this is what a typical architecture of like 150% would go with, whereby they are using Python to pull data from the API and they are storing it in the database, and they are using an orchestrator to orchestrate each pipeline, each task in the order in which it needs to run. So this is a typical or a sample now serverless architecture, and this works fine. There's nothing wrong with it. If you should do this, good, it works fine. But I'm going to share just one point about how this architecture might not be the most cost-effective architecture for this use case. Now, the challenges with this architecture, or the challenge with this architecture, is that you are going to be spending more than you need to run this project. And to go back to the architecture now, the normal deployment style, or the deployment advice that they normally give, that when you want to deploy orchestrator to production, is that the orchestrator would have its own machine, and we are going to have another machine as a worker service. So, but let's say we want to use just one machine for worker, orchestrator, and all those things. So the job will be running on the same server. Now, the challenge with this architecture is that it costs a lot of money. At any point in time, if you want to go either way, you would have at least one machine running, one maybe EC2 machine running, and this service can be very, very expensive. So just to do a small calculation on how much this architecture would cost. So let's say you want to run everything in just one server, and you'll be needing at least an 80 gram EC2 machine. And let's say it is a general purpose compute. So 8 gigram, 2 Basha CPU. When I did this on the AWS pricing calculator, AWS estimates that I'm going to spend in about $100 per month just to run this. So, and a season span across, is it 9 months now? So if I'm going to spend in $100 per month, $100 times 9, that is $900 just to pull data from API, and this is not inclusive of storage. I'm just talking about these two guys here. Storage is not added. So the cost of this pipeline, so let's say you're not even paying $100. Let's say it is even $50 per month, which would not be. That's around $450 or $500 for the whole duration of the project. And this is still a lot of money. Now to go to the serverless architecture, which will be proven to be the most cost-effective architecture for this use case. So this particular architecture is very, very similar to the previous one. The only difference is that, I mean, we're still running Python here, The only difference is that instead of using an orchestrator like the open source orchestrator now, we are using these two services in place of the orchestrator. Now, these two services are serverless. That means they don't need a server. They don't need a compute to be up 24/7. And the beautiful thing about serverless services is that you only pay for what you use. So if your code is running for like 30 minutes a day, you're only paying for that 30 minutes. But in a non-serverless architecture, and that you're going to be having a server up 24/7. Even if your code is not running, you'll be paying for the time that the server is up. So some people might argue that maybe you can be running a bash script to maybe stop and start the server or something like that just to save cost. But I think that that is very, very complicated to do. And with that, you're still even going to be spending, might not be much, might not be like up to what you'll be spending if it's up 24/7, but it's still going to be a lot. Now, the major advantage of this architecture to the non-serverless architecture is the cost of running this service. Will you believe that if I should tell you that you can run this architecture that you're looking at for a period of 9 months and it might not cost you anything? Please, I would like a response. I don't know if anyone wants to object that can be true, that I'm going to run this architecture online for 9 months and I won't pay a dime. Whereas for the non-serverless architecture, I'll be spending at least $500. So is there anyone in the audience that disagree with this? Okay. Let me just proceed. I don't know if anybody's dropping chat. Oh, okay, it's really interesting. All right. So yeah, these services, yeah, someone wants to say something.
I think, can you hear me, guys?
Yeah.
Yeah, I said excluding the DB, right?
Yeah, excluding DB.
Okay.
In the previous architecture, I did not consider the DB. I was only consider the compute needed to run the code and the orchestrator. I'm not counting the DB.
Okay, all right, thanks.
Okay. So, and the reason why this will cost us $0 for the old duration is because of the generous free tier of these services. So for AWS Lambda has a free tier of 1 million run. So per month. So for me to exceed that free tier limit, that means I would need to be running, that is 1 million runs divided by 30. That's around, is it 30,000 now? Yeah, I will need to be running that particular function 30,000 a day just to exit that free tier limit. And even after exiting that free tier limit, the price for Lambda is ridiculously low. Now, same thing with step function now. Step function gives us a free state transition of, I think it's 1,000 state transition free per month. And we are going to go into the how to calculate the number of runs needed for this. Why it's less is because of the free tier. That is why we're not going to be paying any money for the duration of the run. But let's say we are even exceeded the free tier. Let's say the free tier exclusive. We are not considering the free tier now. So maybe AWS will up one day and say that, okay, we are not offering free tier for these services. To run this service, I will need to do the calculation, but this service will not cross $10 per month to run. And that $10, I'm even exaggerating. Now, before we go into the practical session, I've talked about these two services that we're going to be using. And another one that we're going to be using, which was substitute for the orchestrator, is EventBridge. Step function is an orchestrator, but it doesn't have the ability to start itself. So this is where EventBridge comes in. This is just like a scheduler whereby you need something to run a specific, you need a service to start a specific time. You can use EventBridge to start a service. And we are going to be using a planet scale DB. And they offer a free tier MySQL database. And the free tier limit is very, very generous to run a side project for that duration. So an alternative would have been Elephant SQL, SQL, sorry. But the limit of that one is that it has a limit to the number of connections that you can have open. So if you should hook maybe BI dashboard, or you hook something else, maybe a Streamlit application for cataloging or something like that. So at a point, you'll be running into issues. So that is why PlanetScale was used. So a service here that you might be seeing, which some people might not be familiar with, is what they call serverless framework. And this is an infrastructure and code tool which you can use to deploy serverless application to the cloud. So an alternative that we'll be very, very familiar with is it's called Terraform. And there is another one that is also very, very popular, which is Pulumi. So yeah, serverless framework is very, very common with the people that deploy serverless applications to the cloud. So I will be going into the practical session. And before going into the code, I'll be taking us through the different, good afternoon. I'll be taking us through the project that we want to build today. So this fantastic Premier League pipeline had a challenge. And the challenge with this FPL pipeline is that we don't have a specific schedule to run our jobs. So for example, now for people that is very familiar with Premier League, we know that a particular game week can span, doesn't have a specific, a game week does not have a specific time frame. You can say a single game week will span from Friday to Sunday, or Friday to Monday. A game week can be Wednesday and Thursday. A game week can be Friday. A game week can be anything. So if we are going to the API to call to maybe to get standing, it's going to be returning data based on the current game week. So let's say I am calling it maybe a typical game week runs from like Friday to Monday. So maybe I scheduled my cron to run every Monday night or every Tuesday morning. So if a particular game week is Wednesday and Thursday, that means I'm going to be missing out on that game week. And that is the main reason why we need an orchestrator here, why we can't just schedule the different Python files separately. Now, to go into what we are going to be building today, this is a screenshot of the workflow of what we are going to be building today. And this is very, very, I wouldn't say similar to one of the orchestrator, but this gives like a visual representation of what is happening. So when this step function starts, it runs, let's call it task. It gets standing task. And based on the output of that task, it decides what to do. So in this get standing, we have a function that checks if the last game for that current game week has been played. So if the last game has been played, that is true, it runs this other one, which is get fixtures, get players, get managers team, and managers transfer, then sources. If the last game has not been played, it comes here and end. And this is scheduled to run daily so as not to miss out on any game week. So if it runs Monday night, it checks for that current game week, has the last game been played? If it has not been played, it skips it and runs the next day like that. So this is what was used to avoid missing out on game weeks. So now, to go through the API of each one, I created a notebook. and I won't be coding live to avoid my village people messing with my code. So the first endpoint that we are going to be hitting is the features endpoint. So let me just run this. And I'll be using pandas just because of this library. So what JSON normalize does is that it converts JSON data to semi-structured data into structured formats. So trying to write a code to pass JSON data can be very, very complicated at times, but this just gives you the ability to just do it straight without much stress. So if I should run this and do my df, I can see that it's giving me all the fixture for the current season. So this is 38. A season have 38 game weeks. So now the challenge here is now that, okay, I need to be implementing my game week. If not, I will be getting the same game week every time. So if someone wants to deploy this pipeline, there needs to be an initial insert into the game week table. So let's say you're starting this at the beginning now, you need to insert maybe one into the game week to specify the current game week. So because of the current season has gone far, we are in game week 29. So we are going to be specifying the game week that we are interested in. So now we've gotten the pictures data, and now we need to select for the current game week, which is game week 29. And if we should do that and run this, it is giving us the game week for this week, which are just 4 matches. And you can see the status here, finished, is equal to false. So if I should come back after like 2 hours, I think this game week has started. This particular game has started. You can see started is equal to true. Status is equal to true. So, and the stats are also here based on the yellow cards, goal scorers, and assists. So for this particular pipeline, we are going to be using this column to check if we need to proceed to get the standing. So after the last game, FPL updates their league table, do all the calculation. So let me see if I can open 1 second, a link so that I can show you what I'm talking about. 1 second. Sorry, 1 second. So this is what a typical league table looks like. And because of the first match of the game week just started, you can see this game week point is 0. So if we should call the API now for this standing data, you are going to be getting 0 as a game week point. And this is not the right data because of this is yet to be updated. So this should only be fetched when the last game has been played. Now, so to get the last game, we can easily just do log -1 and do was the finished. So based on this condition now, we can decide to move forward or not. So as this is false now, we know that we need to skip this because if we should proceed, we are going to be getting an incomplete data. And from this season, I realized that this is also not foolproof. And an example would be for people that watch football would be the Bournemouth and I think Brentford game that was abandoned, and that particular game week was left open for a couple of weeks, which and the score was not added to the league table. So The data for that week now will be incomplete because of FPL itself did not update that week fast. So this approach is not totally foolproof, but at least for most of the weeks, this is going to work. So let's say this, now we can proceed to get our standing. And from the standing endpoint, this is the endpoint here, and this is the league ID. And you can get your league ID from going to your league on the web page and getting it here. So if you should go to your league, the number that you're going to see here will be your league ID, which you'll be sending to this endpoint. And from the number of managers in your league, it can span across several pages. And you want to make sure that you're not just getting for the first 50. If your league is having about 1,000 managers, you will want to make sure that you are getting everything. So that is why we are having a while through here. So if you should call the API endpoint, it returns a, as part of the response, if there's the next page, and it is called as next. So let me run this. Second page is not defined. One second, please. Page custom one. Okay. You can see this looped through times because we are in that current league, we are having about 53 managers. So let me print out the response to see what we fetched. So 1 second. So this is the standing as it is. And when I went to the web page, this is what it looks like. The event total is the total point for the current game week. And this is the player name. This is the rank, the last week rank, the rank sort, the total points, and the manager ID and the club name. As you can see in this league, this person is the first with 1796. And this is where I am. 29th with 1528 points. So maybe we should go ahead and get the standing for this current week, which is game week 29. We are going to be getting an incomplete data. That is why we need to wait for the last game to finish before we get this data. So if we should come back maybe around 11 p.m. today, this will have updated from 0 to maybe, depending on what this person is called, maybe 70, maybe 50, and likes like that. So after fetching the standing now, we need to save it to the database in a standing table. And this is what we are doing here. So we are adding a column to it for the game week because of the response from the API does not include game week. And the purpose of this, one of the metrics that we wanted to track at the beginning was we wanted to see how a manager performed over time. So at the end of the season, we are going to be having something like a reason chart that you can see. There's this visualization that is popular on LinkedIn whereby you see like moving maybe bar chart or bubbles over the years. You can see 1970 like that. So at the game week 1, you will see the first manager, second manager, and you can see how they are moving up and down for each of the game week. And to do this, that means we will need an additional column to tell us that, okay, this data point that we are looking at is this current game week. So that is why we are creating a new column here called game week. And based on the current week, we add it and also created a unique column because we were not sure about the uniqueness of these IDs. Now, and why did we create this? So let's say, okay, let me do an example now. So let's say we've already gotten the data for this current game week, which is game week 29, and we've saved this. Let's say, for example, let's say for some weird reason, the same code triggered again 2 times that particular day. So to avoid having duplicates, that is why we are creating a unique key that we can use to enforce a constraint to make it like, what's the word now? Is the word idempotent now? So if I should run this code 10 times in a single day, I won't have duplicates standing for a single game week. So it deletes all the records, all the keys, all the records where the key matches before inserting. So even if I'm running it 100 times a day, it doesn't affect my destination. So without this, if I should run it 2 times, this will be populated twice in my database. And that shouldn't be happening. So after doing this now, this is the end of the standing. This is the end of the standing DAG. Let me call it DAG. So after standing, we are moving ahead to get features, players, and managers team. And I'm going to be walking us through the code, through the actual code. Now, this is the code to pull data from the fixture data, and this was written in a way that it can easily be edited. It will require less edits to actually, maybe if you want to run it locally with an orchestrator, you won't have to do much edits to it. So that is why we are having a lot of functions. So first, we start by getting the environmental variable, then we call the features API. And when we call the features API gives us all the data for all the season. So if a particular game week has been played, if you should get the feature data for game week 28, game week 29 will not be showing anything because it is yet to start. But if you should call it this game week, some data will have been updated. So, and that is why we are using replace, because of there is really nothing to track here. So that's why we are using replace here. So this is pretty straightforward. And one of the questions that some people might ask me is why an orchestrator would be a good option to use compared to serverless, compared to step function in terms of alerting and retrying and all those things. So though step function has this retry ability built into it, but I also believe that one can build retry and alerting into the code, even if the particular service does not have that feature. So that is why I have a send email here. So it's an utility function that, depending on what happens. So let's say, for example, now, let's say I made an update to the code and I mistakenly removed the environmental variable for the database. So if this code should run, it won't be able to see the environmental variable, and it's going to send me an email and just return. It will run the function. And I will get this in my email box that, okay, this function failed and this is the reason. So in this code, I built alert into it, and I'm having this utility function almost everywhere, sending emails if a particular error is happening. So for here now, so if an error should occur here, it catches the error and sends it to me as a message. And if, let's say, we have multiple recipients for this, I can just add another recipient for this message and say open, and also pass the person name. Second, this should be. So this would send the alert to these two individuals. Now I'm going to run this locally, and I'm going to purposely break this code. And let's see if it's going to send an alert. What should I break? So let me remove this. And I'm using Poetry for my package management. So a popular one that we might be familiar with is File EMD. And that is also a good option, but I just love Poetry. So it acts as my package manager. And if you want to use Poetry to add your dependency, it's just to do Poetry, add then the library name, and it automatically populates this guy here. You can see the dependency here. But I've already installed this, so I don't need to do this anymore. So I'm going to activate my environmental variables with this, and I'll be running that particular code. So let's give it a minute. As you can see, email sent to this person and also email sent to this person. So if I should check my mailbox now, I'll be seeing this email. So let me see if I can check this. 1 second. Network. Okay. As you can see, it says that error message, load fixture status 1 position argument, but 2 we are given. So that means the alert works. So so if I need this, I might not necessarily, if the orchestrator that I'm using doesn't fully do this, I can just add this to my code. So let me just walk through the other codes for the other endpoints before you move into deploying this to AWS and also creating the orchestrator and running everything. So I've talked about standings, I've talked about features. So the next one is the managers team. And for the managers team, sorry, this is not supposed to be here. So before I get the managers team, I go to the managers table. So now this is dependent on the managers table. So if the managers table is yet to populate, this would fail because of it won't be able to get the managers. And the reason why we are getting managers before we get the team is because of new managers might join the league after the season has started. So I think we had a manager join the league. I think at game week 7 or game week 8. So you want to make sure that we are not leaving any managers behind. So we get the managers, and if there is no manager, we just come out of this function and stop. Well, if there is, we get the game start for each of the managers. So the code is pretty basic, so I'll not be spending much time there. So for the manager transfer, this code gets the transfer made for each of the manager. So for a particular game week, people can trade players. So let me go to the UI to show you. So for a particular game week, second, I can decide to remove a player and select another one. So this event now will be recorded. So for a single game week now, one can actually tell, okay, for game week 28 in this league, these are the players these are the most bought players for all the managers. Maybe 10 managers brought in this particular guy this week. So you can see what the players people are buying in your league. So that is why we are having the managers transfer. And the last one, which is the players. So now this gets the details about the player. So, and for these endpoints, it only gives you the data for that particular game week. So if you are not appending this data, you might not be able to tell some things. For example, now might not be able to tell the value of a particular player across several weeks. So another metric that we wanted to show was like how many people are buying this player for a particular game. So let's say in game week 1, this player is owned by 10,000 managers. Game week 2, it reduced to 9,000. Game week 3, it jumped to 50,000. So you can actually see, okay, how many managers are owning these players across time. So that is why this is not being replaced. And the same thing that was done for standing is done here. We are appending the game week. So just to make it unique and also appending. Without this game week now, we will not be able to make it, what's the word again now? So if this code should run multiple times in a single game week, we are still going to have the same result. So now we've completed the code. Now, how do we deploy this code to AWS? And that is where the serverless framework come into play. And there are two approach that we can take to deploy this. So one is to have like a serverless to deploy using serverless framework. You will need to have a serverless.yaml file in your project directory, and you can create your function. So I have one here, so I'm just rename this to serverless.yaml. So if I should open this, you start by giving a service name, the framework, the role. So this role, you can be any role, but you just need a Lambda full access permission. So you can just go to IAM roles. 1 second, network is pretty bad. I got. So you go to roles, create role, AWS service, and you can choose Lambda. Then next. Now, there is this principle of this privilege. So that means, I mean, you can give this particular role like administrative permission to be able to do anything. But because of this particular role, we want to use it for Lambda just to run Lambda. So that means it just needs the particular permission just to do its job. It's bad practice to give a particular role more than what it needs. So I'm just going to search for Lambda full. 1 second. What was the name? 1 second. Okay, this is it. Lambda full access. We select these. You can see these are the actions that you can take. And these are all it needs to actually run just fine. So after selecting these, we go to next, give it a name. And after this, we can create. Then after creating, you can view role and copy this ARN and just have here. So, but I'm using a variable here to specify the AWS account ID. Because of our previously configured this computer with my AWS account, I can easily reference my account ID to your computer. And after installing AWS CLI to add your access key and secret key, you can just go to AWS configure, and it's going to ask you for the access key, and the next one will be the secret key. Because of our previously done this, that is why it is showing this. And that is why I can reference the account ID here. So in this place, I'm just specifying the provider name that, okay, I'm deploying to AWS, the stage, the Python runtime, the timeout, memory size, and the region. And I'm specifying environmental variable. And I'm also now specifying each function. So we can go like this, but one of the problem, I won't call it problem like that, is that if I should deploy it with this particular serverless.yaml file, so let me just show you. So 1 second, I need to change my region. One second, .aws, okay.
To deploy this data pipeline to AWS, we are going to be making use of the serverless framework, and we're going to be deploying each folder as a separate Lambda function. I have two of the serverless.yaml file open to show that they are the same thing. The only thing that is changing there is the service name. So I'm going to be explaining what each section is and what each key is doing. So in this first place, we are specifying the service name. And in this next place, we are specifying the plugin. And what this plugin is helping us to do is to helping us import the environmental variable from the subfolder directory. So if you ever used the .env library in Python, this acts the same way. You know, when you use the .env and you load it, you'll be able to access the keys that you have in your env as normal environmental variable. There are lots of other plugins that extend the capability of serverless framework. So the next one is the provider section. And the first key here is we are specifying the role that will be assigned to the Lambda function. And the next one, you are specifying the cloud provider, which is AWS. You can use it to deploy to other cloud providers. In this next place, we are specifying the stage, and we are defining a variable that will be passed to this when the serverless command is being called, and it defaults to dev. So if the stage is not passed, it's going to default to dev. In this next place, we are specifying the runtime for the Lambda function. Then we are specifying the timeout, and this should evaluate to 50 minutes, which is the maximum limit for Lambda function. In this next place, we are specifying the memory size for a Lambda function to 512 MB. And in the next space, we are specifying the region to deploy the Lambda function, which it defaults to EU West 2. So in this place, we are specifying the function block, we are specifying the function name, but serverless framework doesn't use this only for the function name. So it concatenates the service, the stage, and the function name. So this will be fixture dev lambda. That is what serverless framework we use as the function name. And the next is handler. We are specifying the root file and the root or index function. So when this function is triggered, it's going to go to this file and look for this function and run. And this is a description, and this is layers. So one thing about layers is that in AWS Lambda, you can't use, there are some libraries that are not out of the box as like Lambda, SQL Alchemy, and Co. You can just import them and start using. And there is no place in the normal environment, your local environment, you will need to run pip install pandas or pip3 install pandas, depending on the operating system that you are using. And in Azure Functions, you just need to put it in your requirement.txt, and it's installs and packages it when you're deploying. But when it comes to AWS Lambda, you need to do this process separately and add it to the function as layers. And I'm going to be taking us through the process. Because of the process require like 3 or 4 different steps. And for someone that uses serverless, that uses Lambda a lot, I have a makefile that does this for me. So makefile is almost the same like bash scripts. I think for me, the only difference that I see is that I can actually group different bash command into sections, and I can run a particular section. For bash scripts, I would have to have each of these as separate bash scripts. And that means I will still be running a lot of commands. But with this, I can just run a single command. So these are different sections. And I have a section that runs all of that section. So I can just run this section, and it's going to create it, zips it, and publish the Lambda layer for me. And looking at this publish layer, I am using the AWS CLI to publish the Lambda and specifying the layer name and specifying the location of the file, the location of the zip file, I'm specifying the region, and I'm saying that, okay, pipe the output, the response to this output.json. So this is an example of the response that one would get from the AWS CLI when you publish a layer. And this is an example of what I have in my serverless.yaml file as the layer. So after doing this now, if I want to run this, I want to deploy each of these serverless functions. To deploy this now, one by one, I would need to seed into each of the folder and run SLS deploy. I can pass the stage and also the region. But because of, if you're having a lot of functions, to do this one by one is like stressful. So I have another make file that does this. So the title name is push because of I can't have two files with the same file name yet. That's why I have this as push. And you can see, seeing it as a batch script. So now I have different sections if I want to deploy a single function or if I want to deploy all. So what this is doing is that it's going to change directory into the argument that I passed, and it's going to run this command in that directory, and it tells me that this is done. If I'm deploying all, it's going to iterate through each of the subdirectory. If there's a serverless.yaml file there, it runs the command. And it's the same thing for removing, just deleting the resources. So, and one of the beautiful things about IAC, infrastructure as code tool, is that it is easy to provision and destroy resources with just few commands, instead of trying to go to the portal and click delete multiple places. So this is everything about serverless framework. So to deploy this, I just need to go to the root directory and run make and then -f push. The reason why I'm having -f is because of the make file that I want to run is not titled make file. So after specifying the file name, I need to specify the session I want to run, and the session I want to run is deploy all. So this is going to skip all the deployments. I'm not sure that I've made any updates to the file. So, and the reason why it's going to skip is because of there is no new change to deploy. So I'm going to be adding to AWS portal, and I have this deployed beforehand. So let me just hide this. Okay, so I have this beforehand, so I've deployed these. These are the different functions that I've deployed. And if I should head over to the step function place, so, and I've had that designed also. So, but I'm just going to go and create a new step function just to see how to do this with the visual UI. Step function has a steep learning curve, but the visual UI sort of lower the barrier for people to use step function. So when you search for step function, depending on if this is your first time of using step function, you might be seeing a different UI. But when you click on new, you might see this. Depending on region, you might see some other things. But we are going to be using a blank canvas. And when you click on create, you'll be seeing something like this, just start and end. And you can start dragging stuffs to it, different actions, and there are different flow. This is an if else, okay, if this is equal to this, or if this should happen, run this. If this should happen, run that. For this parallels, if you want to run, maybe you want to call multiple service or multiple Lambda function simultaneously. So to build what we have here, so let me just do the upper parts. So the first thing is to call the first Lambda function that checks if the last game has been played. And if the last game has been played, that same function get the standing. So I'm going to rename this to get standing. And the reason why I'm renaming this to get standing is because so that someone can actually tell what is happening without not having to like start going to the portal or looking at the JSON for step function to know what is happening. So after giving the state a name, I will need to select the name of the Lambda that I want to that I want to call. So I'll be selecting the latest. And the reason why I'm selecting the latest is this Lambda can be updated. So if this Lambda is updated, I don't need to come here to come and update the Lambda this thing. That's why I'm not selecting one. So I've selected standing def Lambda as this. So this is returning a JSON response. So if I should go to standing Lambda dot and in this place, it is returning, this is not supposed to be here, last game played. So this is what we are going to be using for our if else logic. So let me copy this now. So if the last game has been played, this would output the JSON to be true. If it has not been played, it's going to output it to be false. So before going forward, we need to add like a flow here that will check the output. And based on the output, it runs some other step. So I'm going to drop this choice here, and I'm going to rename this to is last game played. And I'm going to be creating different conditions. But in this case, we just have two conditions, which is true or false. I'll be creating the first one for true. I'll click on the edit button, add condition. Then in this place, to reference a JSON key from the output, they've already given us like a placeholder. It starts with the $, then dot, then the key name. So in this place, it's going to be $, dot, the key name, which is last game played. And we're going to choose the operator. So there are different operators to use here, but what we are going to be using is going to be is equal to, then we select the value. So the data type of the value. In this case, we're using a Boolean constant, which is true. Then we click on save condition. Now we need to, this is the condition here. Now we need to add the second one for false. So when a choice is dropped in this canvas, it comes with a default rule, which we are going to delete. But we can't delete this now. At least one needs to have two conditions here. So we need to create the second one before we delete this, the default one. So it's still the same step. We click on add condition, $, dot, this last game played. We choose an operator, then the type, and we select false. Now we can delete the default one. Just click clear. Now we just have two. So if the last game has been played, it branches here. If the last game has not been played, it branches here. So if the last game has not been played, we need it to go straight to the end, which is success. We just drop this here. So that means the run was successful. And if the last game has been played, we need to run some other Lambda functions. And we want to run some simultaneously. So we need to drop this parallel flow here. And after this, we can drop each Lambda function here. Let me close this. Let me drop the third one. And I can rename this to their various name. So it gets players. Now I need to select the player Lambda function. So let's give this a minute. This is loading. It's due to network, that is why, okay. So I'm going to select the players Lambda function here, and I'm going to do the same thing for this one. This is going to be get fixture. Then we select the fixture Lambda function. This get managers team. Then we select the, oh shit. One second. Okay, sorry, I mistakenly closed that window, but I believe that we've gotten the gist of how this particular we've gotten the gist of how this particular graph was created. So I'm going to execute this just to trigger the workflow and for us to see how how it's going to run and the output of each. So I've done that. When we click on start execution, it's going to ask us to give a payload, but we can leave this as default. Then when we click on start execution, it's going to run the workflow. And based on the output, it knows what to do. So it is running the get standing now, and you can see this is the payload that was passed to the get standing function. So let's wait. So it returned its last game played true because of the last game week there is 27. So it ran these three serverless function, Lambda function simultaneously, and this workflow has completed and everything was successful. So let me just trigger this again. I think I will need to trigger it like 2 more times for it to just go straight to success. Now, this is game week 28, which has been played. So now it's running it again. And for every run, it increments the game week by 1. So this is game week 28. So if I should go to DB and select from the game week table. So 1 second. So this is loading. So this should be the maximum game week there should be 28. Let me do to network. This is taking so long time. But let's head back to AWS. So now I'm going to trigger this once more. Let me trigger this once more. Okay, now it went to success. So that means it has gotten to a game week where the last game has not been played. So now it's went straight to success. So if I keep running this, it's always going to be coming to this space because of the current game week that it is in has not been played. So let me just run that once more. So it's going to, like, it did not even, it took some few seconds before it defaulted to success because the last game has not been played. So now we've developed the workflow, but we are having to run this. Workflow, and this is not completely automated because we can't be waking up every day to come and run this. So to do this now, we need to schedule this state machine to run, and that is where EventBridge come into play. So we can go to EventBridge and from there click on this, but because of AWS knows that we need something to trigger this, they have a drop down here that one can click, and it's going to take one to the EventBridge place. So in EventBridge, there are 2 ways to schedule things. You can either use the EventBridge rule or use the EventBridge scheduler, which was recently made available for everyone. So let's give this a rule name called FPL states. So this can be anything. We give it a description, which is optional. You can select an event boss. If you have like multiple event boss, you can choose the one that you want to use. So there are 2 options here with an event pattern or on a schedule. Because of our use cases on the schedule, we need to run this maybe every 24 hours or every day. We are going on the schedule. And as you can see here, AWS is telling us that, okay, they have a new stuff that we can use to schedule and all those things, but we are going to continue with the rule 1, and here it's asking us, okay, do you want to use a fine-grained schedule that run at a specific time, or we use a schedule like this that runs at an interval. So we're going to be using this, maybe let's just say every 24 hours. So you can also use cron, or you can use this. So we're going to say every 24 hours, we click on next, and yeah, we are going to specify the target that we want to trigger. So in this place, we want to trigger a step function. We will search for step function. As you can see, it's bringing it up here. And after selecting the step function, it's going to ask us to select the step function that we want to trigger, which is the FPL dev. And yeah, you can choose to create a new role or use an existing role, depending on if you have an existing role that you can use. So I'm going to select an existing role, leave the remaining thing as default, click on next. I can decide to use a tag. So let's say here, and click on next. And it's telling us what is going to be happening. Then we can create a rule. So now after creating this rule now, this EventBridge now will be calling the state machine every 24 hours. And that is that about the serverless pipeline. This is now completely automated. The state machine will be called every 24 hours. And depending on if the last game has been played, the step function knows what to do. So to go back to this, now during the presentation, I said that the serverless architectural way is the most cost-effective way to go, and to prove that, this is a screenshot of the cost of running the same pipeline in AWS in September. As you can see here, I mean, since September, it has been $0. And if I'm to run the same data pipeline in a single EC2 machine, this is the estimate this is the estimate I got using the AWS calculator, where I'm using an on-demand instance. I think this was a general compute 8 gig RAM, 2 virtual CPU, and this is going to be costing me $66 per month. So an average season goes for around 9 months. So $6 times 9, that is over $500 for to run this project for a season. And yeah, I've been running this same pipeline using the serverless service. And if I should run this indefinitely, this would not exceed $2 per month, even if I should after the free tier has been exhausted. Let's say AWS wakes up one day and say that no, there is no longer free tier for Lambda and Step Function. This pipeline will not exceed $2 per month. So that is the difference in cost between $0 and $500. Yeah. So that is going to be all about the serverless data pipeline, and this code will be made available. Everything will be pushed to GitHub, and the repository will be shared. Thank you very much.